mirror is kept constant, object is moving with velocity v, at that time what is the velocity of image? Minus v naught. Same velocity of the object only, but in which direction? Opposite direction. Where is Girish? Absent. ಮತ್ತೆ ಬೇರೆ ಯಾರು ಆಬ್ಸೆಂಟ್ ಇದರಲ್ಲಿ? ಗೌತಮ್ ಎಷ್ಟು ಸಲ ಹಾಕ್ಕೊಂತಾರ ವ್ಯಾಕ್ಸಿನು? ಡೈಲಿ ವ್ಯಾಕ್ಸಿನ್ ಏನು ಅವ್ರಿಗೆ? ಇಲ್ಲಾಂದರೆ ಇವ್ರೇನು ICMR ಅವರು ಇವ್ರನ್ನ ಟೆಸ್ಟ್ ಟ್ಯೂಬ್ ಥರ ತಗೊಂಡಿದ್ರ, ಟೆಸ್ಟ್ ಪರ್ಸನ್ ಥರ ಪೇಷಂಟ್. ದೆನ್ ಗೌತಮ್ ಅಂಡ್ ದೆನ್ ಗಿರೀಶ್ ಆ್ಯಂಡ್ ತರುಣ್. ತರುಣ್ ಆಲ್ಸೋ ಆಬ್ಸೆಂಟಾ? ದೆನ್ ಮತ್ತೆ ತಾವೂಸ್ ಆಲ್ಸೋ ಆಬ್ಸೆಂಟ್. ಊರಿಗೆ ಹೋಗಿದ್ರಾ? ಇವಾಗ ಹೋಗ್ತಾರಂತ, ಬಟ್ ಈಗ ಹೋಗಿದ್ರು ಅವರು. ಮತ್ತು ಬೇರೆ ಯಾರಿದ್ರೆ? ಯತೀಶ್ ಇಲ್ಲಿ ಓಕೆ, ನೀವು 3 ಅಷ್ಟೇನಾ? ರಮೇಶ್ ಹೋಗಿ ಮೇಡಮ್ಗೆ ನೇಮ್ಸ್ ಬರ್ಕೊಂಡೆ ಕೇಳು. ಗಿರೀಶ್, ತರುಣ್, ತಾವೂಸ್, ಗೌತಮ್. ಅಷ್ಟೇನಾ? ಮತ್ತು ಯಾರನ್ನ ಇದ್ದಾರಾ ಮಿಸ್ಸಿಂಗ್? ವೇರ್ ಇಸ್ ಅನದರ್ ಜಮಖಂಡಿ? ಆಕಾಶ್ ಅವ್ರು ಕೂಡ ಹೋಗಿದ್ರಾ? ಮೇಲೆ ಇದ್ದಾರಾ? ಏನು ಮಾಡ್ತಾಯಿದ್ರು ಮೇಲೆ ಅವಾಗಿಂದ? ಮಾನಸಿಕ ಆಗಿಬಿಟ್ಟಿದ್ರಾ? ನಿಮ್ಮ ಎಫೆಕ್ಟ್ ನೀವೇ ಏನೋ ಮಾಡಿರ್ತೇವೆ ಅವ್ರಿಗೆ. Right. Yeah, we were discussing about the velocity. So,
Sorry, I didn't get that.
So, velocity of object is v naught, nothing but in front of the fixed plane mirror it is going. At that time image velocity will be exactly object velocity but in opposite direction, minus v naught. One more is, whenever the mirror is kept fixed and then object is moving parallel to the mirror, at that time what is the velocity of image? Velocity of he is in there in hostel. You are not going to hostel. You go there. I have given the name already. ಇದು ಅಂದರೆ ಕೂಡ ಏನು ಪ್ರಯೋಜನ ಇಲ್ಲ, ಹೋಗು. ಆಲ್ರೆಡಿ ನೇಮ್ ಕೊಟ್ಟಿದ್ದೀನಿ, ನಮಗೇನು ಗೊತ್ತಿಲ್ಲ. ಹೋಗ್ತಾ ಇದೆಯಾ? ಈಗ ನೀವು ನೇಮ್ ಕೊಟ್ಟಿದ್ರೆ ಯಾಕೆ ಇರಬೇಕು ಇಲ್ಲಿ? ಸೊ ವೆನ್ಎವರ್ ದ ಆಬ್ಜೆಕ್ಟ್ ಈಸ್ ಮೂವಿಂಗ್ parallel to the mirror, at that time what is the velocity of image? Velocity of the image is equals to velocity of object. Same direction or opposite direction? Same direction. Now here object is kept fixed. Object is kept fixed and then the mirror is moving in the parallel direction. Then what is the velocity of image? 0. Velocity of the image is equals to velocity of object. Now object is kept fixed and then mirror is moving perpendicular to its direction. Then what I can say? 2 times of velocity of mirror. Velocity of the image equals to 2 times of velocity of mirror. One more thing is, whenever both are moving, at that time what you have to take? Relative velocities you have to take. Whenever both are moving in different directions, at that time what you have to take? Perpendicularly separate and then parallelly separate, and then you have to do the problem by the relative velocity formulas again. These are all the different concepts we have discussed about the velocity of image and also minimum height of the mirror required. And also plane mirrors, whenever I have taken 2 parallel plane mirrors, the reflecting surfaces are facing towards each other. I kept the object in middle. How many number of images? Infinite number of images, and by the cross method only we can get all the distances of images. Then after that, now the mirrors are inclined with each other with angle theta. So what you have to find first? X you have to find out. What is the X formula? 360 by theta. If that x value is even, then number of images are n x minus 1. If the x is odd, at that time we will get the 2 cases. One is on the bisector, another is not on the bisector. On the bisector, what will you get? N is equals to x minus 1. Not on the bisector, nothing but n is equals to x you will get exactly. Then after that we said about the decimal point. For example, my answer is 6.5. How many number of images? 6. Always you have to consider the lower order integer only. This is about the number of images we have discussed in different cases of the plane mirror. Then now we will start the spherical mirrors. Spherical mirrors. See, by the spherical mirrors, everything is just what is that, already everything theory will be there, almost image positions and then image nature and all. In that nature, real will be there, virtual will be there, inverted will be there, erected will be there, enlarged will be there, diminished will be there. So in this type of problem, what they will do, nothing but they will give all the distances same only, all the options they will give the same distance, but they will give the different nature. So nature is very very important. Only two formulas will be there. One is the mirror formula, 1 by f is equals to 1 by v plus 1 by u. That is one formula. Another formula is magnification is equals to minus v by u, or height of the image by height of the object. Only by the two formulas only we will solve everything. But here the important thing is the sign convention of this is important. Instead of taking minus, if you take plus, means your entire answer will be wrong only. So that sign convention is important, along with that nature of image also important, and the place of the image also important, where it is formed. So this is about the spherical mirrors. In that spherical mirrors mainly we will have two types of mirrors. One is concave mirror, another is convex mirror. The concave mirror is also known as a converging mirror. The convex mirror also known as the diverging mirror. For the concave mirror, which surface is reflecting surface? Inner surface, outer surface? Inner surface. For the concave mirror, inner surface is the reflecting surface. For the convex mirror, outer surface is the reflecting surface. So that is about the convex and then concave mirrors. For that we will have different definitions. One is pole, another is principal axis, another is focus, then focal length, center of curvature, diameter, aperture. This and all different definitions will be there, and that definitions will be mentioned in the problems. They will give in the terminology. If you don't know the definition of that, means you cannot understand the problem properly. So that each and every definition is important, that will be very easy to understand also. So that is about the different definitions. After that we will discuss about the image formations. For some fixed incident rays, how the reflected rays will be, that will be one type of methodology. Another type of methodology is, whenever I have taken some fixed incident rays and then object place is fixed, at that time where the image will be formed and what will be the nature of image also. These are all different concepts we will discuss in the spherical mirror. After that we will do some problems based on this magnification and then mirror formulas, and then we will close it. Then we will start the refraction. Okay, minimum 2 classes are necessary for that. Now here first and foremost is the spherical mirrors will be made from the glass sphere. I have taken the glass sphere here. So this glass sphere is having the center here, center point is there here. Now what I am doing, nothing but I am just cutting this, the glass sphere like this. I am just taking this part aside and then this part aside. Let me take, this is a part 1 and then this is a part 2. Now for the part 2 I will take it separately. Part 2 I will take separately, and now what I am doing, nothing but I am painting on outer surface or silvering on outer surface. Then which is the reflecting surface here? Inner surface is reflecting. Just glass only, that is just glass only. One side you are painting, nothing but other side will be the reflecting surface only. If you see that glass only, you are not painting on the other side, but you are fixing into wall, so that surface is obviously closed only. So the open surface is working like the reflecting surface, so only we are able to see our image in that. Clear? So that one side it is painted, nothing but the other side will be the reflecting side. Now here inner surface is the reflecting surface. At that time this is which type of mirror here? Concave mirror. So that cave side, this is like cave, so that cave side reflecting surface is there, so only it is concave mirror. And now whenever I take the mirror 1, first one, spherical mirror 1, at that time what I will do, nothing but I will just paint inner side, then which is the reflecting surface? Outer surface. So only this is known as a convex mirror. This concave mirror and then convex mirrors are known as converging mirror and then diverging mirror. How it will be converging and diverging we will discuss later after discussion of the this one definitions, basic definitions. Now in this definitions are important. The center point of the mirror is known as what? Center point of the mirror is known as pole. That is pole. Pole denoted by P. Clear? Whenever you take the mirror, for that center point is known as a pole. Now, the line passing through the center point is known as what? Principal axis. Principal axis. So, here whatever the object is, object and then image, everything will be placed on this principal axis only. Now, this pole usually we will take as a origin. Whatever the distances we are measuring, we will start from the pole only. That is very important. In the sign convention, it will places a major role. So that you have to mainly understand that pole is a origin only. The line passing through the pole is known as what? Principal axis. Now, here whenever you see this one, the complete sphere, for the center is there. So that center is there here for this. Whenever I take this as a total sphere, at that time this is the center, is known as what here? Center of curvature. Center of curvature. And the distance between the pole and center is known as what? Obviously distance between the edge and then center is known as what? Radius only, right? That is the radius of curvature. Center of curvature and then radius. Now, exactly at the half of the radius, what will be there for us? Focus will be there. What is this focus? Nothing but whenever you take the paraxial rays, what is the paraxial rays? Parallel to the principal axis and which are very closer to the principal axis. The rays which are parallel to principal axis and closer are known as the paraxial rays. For that type of paraxial rays, the image will be formed at the focus. And already I mentioned in the plane mirror itself, in the last week I guess so, the object is responsible by which rays? Incident rays. Object is responsible for the incident rays and image will be reflected rays. The intersection point of the reflected rays is known as what? Image. That is what the image we call. The intersection point of the reflected rays is known as the image. The extension of that reflected rays is at that time which image it will form? Virtual image. Correct? So that is about the virtual and then real we have discussed. That is not necessary now. Now mainly you have to understand that object is formed by the incident rays and image will be formed by the reflected rays. So here, now whenever you see, I kept object somewhere here, otherwise I will keep at the infinity. At that time where the image will be formed, nothing but image will be formed on the focus. Okay, that focus is nothing but the point of image where that image is formed. And also the length between, nothing but the distance between the pole and focus is known as what? Focal length. So only you might be seeing this formula F is equals to R by 2. Do you know that? F is equals to, always we will take it as R by 2. So the distance between the focus and then, Satvika, idara class alle? Hello, hogidare? Kashmir, Ooty. So focus and then pole, the distance between focus and pole. Nimge kalasini, okay Pramod, I understand that. ನೀವು ಅಲ್ಲಿ ನೋಡಿ ನಾವು ನಗಬೇಕಲ್ಲ, ಅಲ್ಲಿ ಯಾಕೆ ನೋಡ್ತಾ ಇದೀಯ? ಮತ್ತು ಶ್ರೇಯಸ್ ಆಟ ಆಗ್ತಾರೆ. ಸೊ focus and then pole I have taken. The distance between them is known as what? Focal length. Correcta? So ಎಲ್ಲರೂ ಹೋಗಬೇಡ್ರಿ, ಇಲ್ಲೇ ಇರ್ರಿ. I'll send you to you people by my own money only. I'll book a ticket and then I'll send you. ಗೋವಾ ಹೋಗ್ತೀರಾ, ಊಟಿ ಹೋಗ್ತೀರಾ, ಕೊಡೈಕೆನಾಲ್ ಹೋಗ್ತೀರಾ, ಸ್ವಿಟ್ಜರ್ಲ್ಯಾಂಡ್ ಹೋಗ್ತೀರಾ? ಏನು ಶ್ರೇಯಸ್, ಇಬ್ಬರೇನಾ ಮತ್ತೆ ಯಾರನ್ನ ಕರ್ಕೊಂಡು ಹೋಗ್ತೀಯಾ? ಯಾರು ಥರ್ಡ್ ಮೆಂಬರ್? ಯತೀಶ್ ಅಲ್ಲ? ಸಿ ಹೌ ಈಸ್ ಸಿಟ್ಟಿಂಗ್ ಜಸ್ಟ್ ಬಿಸೈಡ್ ಆಫ್ ಪ್ರಮೋದ್ ಅಂಡ್ ದೆನ್ ಜಸ್ಟ್ ಫ್ರಂಟ್ ಆಫ್ ದ ಯತೀಶ್. ಇಬ್ಬರು ಇರಬೇಕನ್ಸುತ್ತೆ ಅಲ್ಲ, ಆ ಪಕ್ಕ ಈ ಪಕ್ಕ. ರೈಟ್. ಯಾ, ಫೋಕಸ್. ಫೋಕಸ್ ಹಿಯರ್. Focus here. So focus will be there exactly at the half of the distance of the radius, so that the focal length is r by 2 exactly. These and all are the different definitions. And also whenever you see the minimum distance between the edges of the spherical mirror, nothing but let me take this is point A and then point B, minimum distance between them is known as a aperture diameter. This is a diameter, obviously aperture diameter. Okay, these are all the different definitions. Now let me take, this is the concave mirror I have taken, this is a reflecting side. Now the center point, what is that? Pole. The line passing through the center, principal axis. The rays which are near to the principal axis, paraxial rays. Then after that, what we have discussed here, this one, what is this distance? Aperture, diameter, and then this point is center. Okay na? Half of that point, focus. Distance between the center and pole, radius, and then distance between the center and focus. Distance between the, ನೀವು ಕನ್ಫ್ಯೂಸ್ ಆಗಿ ನಮಗೆ ಕನ್ಫ್ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ರು. So distance between the pole and center is known as the radius, and then pole and focus is focal length. Okay na? ಅರ್ಥ ಆಯ್ತಾ ಎಲ್ಲ? Right, that is about the small definitions. And then always the focal length f is equals to what I can say? r/2, half of the radius only. Now the concave mirror is known as the converging mirror, and the convex mirror is known as the diverging mirror. How it is possible, we will see. Now for example, if I place an object at the infinity, so that I am getting a paraxial rays. Whatever we have discussed yet, all the definitions and then all the formulas, mirror formulas, everything will be applicable for the paraxial rays only. Okay, paraxial rays only we have to consider, by the way, which are not parallel, it is not necessary for us. So here paraxial rays I considered, and then object is placed at the infinity. Now after the reflection, what they are doing, nothing but they are passing through the focus. So they are intersecting here, they are intersecting, nothing but they are converging or not. Intersection is known as a convergence. So that this mirror is known as a converging mirror. Whenever you come to the convex mirror, at that time, let me take again the paraxial rays only I have taken. Then what happens, nothing but whenever I take the plane mirror, I can take that smaller area as a plane mirror only. Very smaller I can take as a plane mirror only. So that plane mirror normal is there in this direction, exactly 90 degrees. Now this will be the angle of incidence. Then where will be the angle of reflection? Same or different? Same only, right? So that in this direction reflected ray will be there. Angle of incidence is equals to angle of reflection. Then after that, again this one is falling on this. Here this will be the plane mirror. At that time I can say this is a normal, this is the angle of incidence. Then angle of reflection also by the same angle only. Angle of reflection, this is a normal. Now after the reflection, they are intersecting with each other, otherwise moving apart from each other. Apart from each other, they are diverging. So only this mirror is known as a diverging mirror. Clear? So that converging mirror and then diverging mirror, all the definitions are important here. Pole nothing but the center point of the mirror, and then principal axis means the line passing through the pole, and center of curvature nothing but center of the total sphere, and the distance between the center and pole is what here? Radius. The half of the radius is known as what here? Focus. The length is focal length. So focus is nothing but the image point for which type of rays? Paraxial rays. Paraxial rays means what? The rays are parallel to principal axis, and those are very near to that. Okay, always nearer rays only you have to consider. That is about the basic definitions. And also the minimum distance between the edges of the mirror, diameter, aperture. Okay, write that. First, spherical mirror. Spherical mirrors are parts of the glass sphere. Parts of the glass sphere. And at first concave mirror. Inner surface is reflecting surface. Inner surface is reflecting surface, and also known as converging mirror. And also known as converging mirror because reflector rays intersect with each other. Reflector rays intersect with each other. All of you have taken 2 assignments of physics? Yes, 2 assignments. Then next one is convex mirror. Convex mirror. Outer surface is reflecting. Outer surface is reflecting. After reflection, rays will move apart from each other so mirror is known as diverging mirror. Draw the first diagram. First sphere you draw, only sphere. Sphere you draw and then indicate the convex and then concave mirror is in that. ಜಾಸ್ತಿ ನೋವು ಬರ್ತಾಯಿದ್ದಾ? Next write the definition. Pole in bracket P, pole P, center point of the spherical mirror. Center point of the spherical mirror. Usually to be considered as origin. Usually to be considered as origin. Next, principal axis. PA. Principal axis. A line passing through the pole. Line passing through the pole. Next, center of curvature. Center of curvature, capital C. Center point of the whole sphere. Center point of the whole glass sphere. Whole glass sphere. Then radius capital R. Radius capital R. Distance between pole and center. Distance between PC. Distance between the Pramod Chopra and then Shreyash Chopra. Very less distance, very close to each other. Whenever I said PC and then he is smiling. ಜ್ಞಾಪಕ ಎಲ್ಲ ಬರ್ತಾ ಇದ್ದಾವೆ ಪಾಪ, ಹಳೆ ಜ್ಞಾಪಕಗಳು. ಮತ್ತು ಪಿ ಸಿ ಆದಮೇಲೆ ಏನು? ಎಸ್ ಸಿನ ಫೋಕಸ್. ಹ್ಯಾವ್ ವಿ ಡಿಸ್ಕಸ್ ದ ಫೋಕಸ್? ರೇಡಿಯಸ್ ಫಿನಿಶ್ ದ? ಎಸ್. ಫೋಕಸ್, ದ ಇಮೇಜ್ ಪಾಯಿಂಟ್, focus capital F. Image point for the paraxial rays. Image point for the paraxial rays. at r by 2, at capital R by 2. Then next, focal length small f, focal length small f. Distance between the focus and pole, distance between the focus and pole, focus and pole, small f is equals to capital R by 2. Next, diameter aperture, diameter aperture. The minimum distance between edges of the mirror, edges of the mirror. Shana, anything we missed? Nothing. Draw the two diagrams, converging and then diverging diagrams. Converging and diverging diagrams you draw, and then indicate everything. Next one, different natures of the image, different natures of the image, different natures of the image. In the different natures, we will get one as real, another as virtual, then another as erected, another as inverted, then enlarged and diminished. So these are the different natures of the images. So first, real. Real nothing but what? Real image means what? Image formed due to what? Intersection of real incident ray, real reflected rays. I'm sorry. Image nothing but obviously image will be formed by which rays? Reflected rays only. So that is a real image nothing but the image will be formed by the intersection of real reflected rays. That is a real image. Virtual image. What is the virtual image nothing but? Intersection of extended reflected rays. Okay, whenever for example if you take this one only, for example there is this diverging mirror only if you take, for that the rays are reflecting in this manner. So I want to form the image nothing but there is no intersection, there is no chance for the intersection. Then what I have to do nothing but I have to extend them in the opposite direction. Then what happen means I can form an image. That will be which type of image here? Virtual image. Why? Because we are extending that reflected rays. It is formed by the real reflected rays, at that time it will be real image. It is formed by the extended reflected rays, that will be the what is that? Virtual image. Next one is erected. What do you mean by erected? Straight, that is by the same orientation of object. For example, I have taken the object in the upward direction. then my image also in which direction? Upward direction only. If image is there in the downward direction, that will be which type of image? If whenever I have taken the object in the upward direction and then I got the image also in the upward direction. So which type of image that is? Erected image. Virtual, real and all just by the rays only we will discuss that. But now I am asking about the erected and then inverted. So I have taken the object upwards means image also upwards. So which type of image that is? Erected image. Whenever the object is in the upward direction but the image is there in the downward direction, inverted. Okay, then my object is very smaller. Object is very smaller. I am getting the image larger. Enlarged image. Whenever my object is very larger, I am getting the image as smaller. That will be diminished. So in diminished, normally in usual life also we will use that word. Whenever you are not able to see anything properly, at that time you can say it is a diminished. Why you cannot see properly means because the object is very small there. Now here object is smaller and the image is larger. Which type of image that is? Enlarged image. Object is larger and then image is smaller means that will be diminished image. These are all the different natures of the images, and also you will get the negative marks here only. If you don't understand these definitions properly, they will give the image distance is same. For example, 30 centimeters, 30 centimeters. One option they will give as a inverted, another option they will give as a erected. If you don't know the definitions properly, then you will get the wrong answer there. So erected nothing but same orientation of object, inverted nothing but opposite orientation of the object. And also enlarged nothing but for the smaller object you are getting the larger image, diminished nothing but for the larger object you are getting smaller image. And also real image nothing but real image will be by the real rays, real reflected rays. Virtual image will be by the extended real rays. Obviously extended real rays nothing but that is a virtual image. These are all the different natures of the images. First write that. Natures of the images. Nature of the image. First one is real. The intersection of real reflected rays. Intersection of real reflected rays. Already we have discussed this in the plane mirror also. Intersection of real reflected rays. Next, virtual image. Intersection of extended reflected rays. Intersection of extended reflected rays. Extended reflected rays. Next one is erected. Erected. The orientation of object and image is same. Orientation of object and image is same. Now if object is there above the principal axis means image also will be there in which direction? Above the principal axis only. Whenever the image is coming below the principal axis, that will be which type of that? Which type of image? Inverted image. Why? Because opposite orientation. Write that inverted. Next one is inverted. Image will be image orientation will be in reverse as compared to the object. Image orientation will be in reverse as compared to the object. If height of the object is positive means height of the image will be negative. Why? Because it will be below the principal axis. Okay, along the negative y axis by the way. And that is about the inverted and then erected, then enlarged. Enlarged. Image will be in larger size as compared to the object. Image will be in larger size as compared to the object. Next, diminished. Image will be very smaller in comparison with object. Image will be very smaller in comparison with object. Which mirror? Concave mirror, huh? Now, concave or convex? So don't remember that left side means concave, right side means convex. Okay, na? So only I ask this. Now, this one is concave only. Same diagram, ayyo. Now, what is that? Not a mirror. Ba, Deepika. Take a bow, Deepika. Aste, mate. Next, there is a duster. Where I kept? Duster illa andre nanu henge rub madidinamma eno deva banta eno rub madake ಕಾಶ್ಮೀರಗೆ ಕರೆದಿನ ನಾನು right. Reflected rays were some standard incident rays. Those standard incident rays are, first of all I will take the concave mirror here and then convex mirror here. Concave mirror is also known as which type of mirror? Converging mirror. Now the concave mirror I have taken. In that, first and foremost fixed ray is which ray? Nothing but that is a paraxial ray. Nothing but the object is placed at the infinity. Whenever the object is placed at the infinity, then only the ray will be the paraxial ray. Now for the paraxial ray, what happens? Nothing but the reflected ray will passes through what? I said already this one in the converging and then diverging diagrams. Focus only, right? For the paraxial rays, the reflected ray will pass through the focus. This will be the focus. This is the reflected ray. This is the incident ray and then this is the reflected ray. That is about the first type of fixed incident ray. Ayyo. What happened? Bhukampa bandida anukunde nanu. Then next one is, whenever the ray is passing through the center, then what happens? The ray is incident and then passing through the center, then what happens? It will reflect back in which direction? Same direction, again same line only, nothing but that is known as retracing its path. So whenever the ray is incidenting and then passing through the center of curvature, then it will retraces its original path. Okay, then third type of ray is, whenever I have taken the same concave mirror again and now my ray is incidenting through the focus, then what happens? See that parallelly coming, going through the focus, then coming from the focus means it will go in which direction? Parallel direction only. So only it will reflect back in this direction, parallel to the principal axis. Then fourth type of ray is, whenever the ray is just falling on the pole, ray is just falling on the pole, then what happens? It will reflect with the same angle only. Okay, this is obviously this is angle of incidence only. Why? Because if I take this as a plane mirror, this will be, principal axis will be what here? Normal. With respect to the normal, it is making how much angle here? Theta means that is I only, obviously angle of incidence. Then angle of incidence is equals to obviously angle of reflection. So reflect back with the same angle only. These are the four incidence rays, fixed incident rays. For that, how the reflected rays will be? First of all, whenever the ray is incidenting parallel to the principal axis, then it will reflect back through what? Focus. Whenever the ray is incidenting through the center of curvature, if it will reflect back also through the center of curvature only. Whenever the ray is passing through the focus and then incidenting, then it will reflect back in the parallel to the principal axis, and also whenever the ray is incidenting on the pole itself, at that time it will reflect back with the same angle. These are the 4 fixed rays. Okay, now whenever you see the first one and then third one, both are opposite to each other. Here incidenting parallelly, reflecting through the focus. Here incidenting through the focus and then reflecting parallelly. Clear? That is about the concave mirror. Then whenever you see the convex mirror, again same only, always we'll consider the left side one is the reflecting surface, that might be concave or convex. That will be easy for the sign conventions. Why? Because if you take again in the opposite direction, at that time it will be little confusing. So that always take left side as the reflecting surface. Now this is convex mirror. Now what happening? Nothing but first one, whenever you see the ray is coming parallel to the principal axis, then what happens? Generally which type of mirror this is? Diverging mirror. So what should happen? The ray has to diverge, nothing but it has to move away from the principal axis. Obviously in this direction it is going. Now where that will appear, like where it is coming from? It appears like it is coming from where? Focus. Other side focus. Other side of the mirror. That is which type of focus? Real focus or virtual focus? Virtual focus. Why? Because this is a sphere for us, original sphere. And then this will be the center, this will be the focus. So always whenever it is there in the reflecting side, at that time it will be real. Whenever it is not in the reflecting side, that will be the virtual. Obviously we know that whenever the focus is there here, this is not the reflecting side, so only this focus is known as what here? Virtual focus. Now whenever the ray is incidenting parallelly to the principal axis, at that time it will reflect back in which direction? Nothing but it will appears like it is coming from the focus only. So it is going from here. Actually if I ask from where it is coming, nothing but you have to say that it is coming from the focus. This is the focus. Clear? Appears, nothing but we are extending in the opposite direction. So which type of focus this is? Virtual focus. Virtual focus. Then next one is second case, whenever the convex mirror I have taken like this. Now here a ray is coming like this, and then it is appearing like it is passing through the center. Then what happens? It is appearing like it is passing through the center. What happens? It will retraces its path, right? So that it will move in which direction again? Opposite direction. It is appearing like it is coming from the center. Initially it is going to the center, finally it is coming from the center. Why? Because it is retracing its path whenever the incident ray is passing through the center of curvature. Already we have discussed the same thing here also. What he is doing, you know, like this, he folded his hand. ನಾವು ಬರ್ತಾ ಇದ್ವಿ ನಮಗೆ, ಬಟ್ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಇಲ್ಲ ಅವ್ರ ಫೇಸಲ್ಲಿ. ಮಾಡ್ರಿ ಯತೀಶ, ತುಂಬ ನಿದ್ದೆ ಬರ್ತಾ ಇದಲ್ಲ. ಏನು ಶ್ರೇಯಸ್, ಏನು ಶ್ರೇಯಸ್ ಫುಲ್ ನೈಟ್ ಔಟಾ? ಅವ್ರಿಗೆ ನಿದ್ದೆ ಬರ್ತಾ ಇದೆ ಇಲ್ಲ, ನಿಮ್ಗೆ ಯಾಕೆ ನಿದ್ದೆ ಬರ್ತಾ ಇದೆ? ಶ್ರೇಯಸ್ ಈಸ್ ಲಿಸನಿಂಗ್ ದ ಕ್ಲಾಸ್. ಏನು ಪ್ರಮೋದ್, ಅವ್ರಿಗಿಬ್ಬರಿಗೆ ಅಭ್ಯಾಸ ಆಗಿದೆ ಅನಿಸುತ್ತೆ. Right. Next, now what happening means, again for the same convex mirror we have taken that the ray is incidenting like this and it is appearing like it is passing through the focus. Then what happens? How it will diverges? Parallel to the principal axis, so that in this direction it will come parallel to the principal axis. Now it is appearing like it is going through the focus only. It is not going in reality, but it is appearing like that. Now it will reflect back in the parallel direction of the principal axis. That is about the third fixed ray. Then fourth one, if I consider, again the convex mirror only. Then what happening means, the incident ray is passing on the pole, then what happens? It will reflect back in the same angle only, theta. There is no change in this. Clear everything, you understand, right? So the focus of the convex mirror is which type of focus? Virtual focus. Okay, don't think about them. Okay, think about the problems. The focus on the problems only. Don't focus on the Shreyas and then Yatisha. Okay. Now the focus of the convex mirror is virtual focus, and then focus of the concave mirror is which type of focus? Real. See that one, you remember any one diagram, then automatically other one you can understand easily. Whenever the ray is coming parallelly, then reflect back through what? Focus. Whenever the ray is passing through the center of curvature, retraces. Whenever the ray is passing through the focus, parallel to the principal axis, and then passing on the pole, falling on the pole, it will reflect back with the same angle. Everything will be same on the other side also. Clear? Copy that. You write the theory by your own. इधे जाते हैं क्या? ಏನು ರೈ ಏನೋ ಹೇಳ್ತಾ ಇದ್ರಿ ಸೀಕ್ರೆಟ್ ಅವ್ರಿಗೆ. ನೀವು ವಾಟ್ರ್ ಕೇಳಿಲ್ಲಲ್ಲ. ಇಫ್ ಯು ಲೈ ಲೈಕ್ ದಟ್ ಓನ್ಲಿ ಇಟ್ ವಿಲ್ ಬಿ ದೇರ್. ನೆಸಿಟಿ ಇಲ್ಲ ಅಂದರೆ ಕೂಡ ವಾಟರ್ ಕುಡಿಯಬೇಕು. Right, next one, relative position of image formed by the concave mirror. Relative position of image formed by the concave mirror. Okay, I understand, but I will not leave for 20 minutes. ನೀವು ಎತ್ತಿ ನಮ್ಮ ತಲೆ ಮೇಲೆ ಹಾಕಿದ್ರೆ ನೀವು ಎತ್ತಿ ನಮ್ಮ ತಲೆ ಮೇಲೆ ಹಾಕಿದ್ರೆ ಅಂದ್ರೆ ಕೂಡ ನಾನು ಹೋಗಲ್ಲ. ಯಾರ್ಯಾರನ್ನ ಫೋಕಸ್ ಮಾಡ್ತಾ ಇದ್ದೀರಾ ತಲೆ ಮೇಲೆ ಹಾಕಿ ಬ್ಯಾಕ್ ಸೈಡಿಂದ? ಏನು ಉದಯ್? ಆ್ಯಂಗಿಲ್ ಕರೆಕ್ಟಿಗಿದೆ, ಆ ಥರ ಇದ್ದೀನಿ ಆಲ್ರೆಡಿ. ಫೋಕಲ್ ಲೆಂತ್ ಕಡಿಮೆ ಇದೆ ಅಲ್ಲ? ಬಾಟ್ಲಿ ಯಾರ್ದು ತೊಗೋಬೇಕಾನೆ? ಸ್ಟೀಲ್ ಬಾಟ್ಲಿ ತೊಗೋರಿ, ನಾಳೆ ರಜೆ ಇರುತ್ತೆ ನಮಗೆ, ಅವಾಗ ರಿಲ್ಯಾಕ್ಸ್ ಆಗ್ಬೋದು. ಪ್ಲಾಸ್ಟಿಕ್ ಅಂದರೆ ಅಷ್ಟು ಜಾಸ್ತಿ ಏನು ಇದೇ ಆಗಲ್ಲ. ಹೋಲಿನಾ? ನಾಳೆ ಆಡ್ತೀನಿ. Right here, first one, these are almost, if these diagrams are finished, nothing but the spherical mirror only finished. Only that mirror formula will be there, magnification, based on that we will do some problems. So these diagrams are important, ray diagrams are important, and by the way you can easily remember them. So first of all, whenever the object is placed at infinity, object is at infinity, nothing but which type of rays will come? Paraxial rays will come, right? So that the paraxial rays are coming here. Not only one, you can take two paraxial rays. You can take two paraxial rays like this. They are coming from the infinity, so that they will, whenever they are reflecting, at that time, from where they will reflect back? Focus only. Whenever they are reflecting, at that time they will pass through the focus. So where the image is formed? At the focus only. Now here I have taken point object. At that time, let me take, we are getting the point image. At that, for example, if I take the enlarged object at the infinity distance, at that time what I am getting? Nothing but I am getting the incident rays like this. And also whenever I get the incident rays like that, for example, I have the enlarged object like this. So from that I can take two rays. Always two rays are necessary. I said already, I think 2 or 3 rays are necessary to draw the image diagrams and all. Now I have taken from the infinity, I am taking the 2 incident rays for the enlarged object. At that time what happens? From where they will pass? Focus only. But if I take the enlarged object, at that time they will pass through the focal plane. What is the focal plane means? The focal plane is nothing but the plane at the focus point is known as the focal plane. The plane which is passing through the focus point is known as the focal plane. Now whenever you compare this object, it is enlarged object, this image diminished, but it is highly diminished. Why? Because for example, whenever you are just sitting in a car and then you are seeing the image of a lorry behind you, whenever it is far away, at that time you will see the smaller image. Whenever it is coming near to you, at that time you will see the larger image. So whenever it is at infinity distance, at that time you will see the highly smaller image, nothing but highly diminished image. So that here which type of image this is? Real or virtual? Real image or virtual image? Real image, right? I am not extending anything, I am just getting by the reflected rays only. Real image. Erected or inverted? Inverted. Then next, enlarged, otherwise diminished, highly diminished. Okay, that is the nature. I will draw all the diagrams, you have to tell the nature like that only. Now this is for the first case, whenever the object is at infinity. Then second case is whenever the object is there beyond C, beyond the center of curvature. At that time I will get the diagram like this. This is the center of curvature and this is the focus. My object is there here. I need minimum 2 rays to draw the ray diagram, so that I have taken 2 rays like this. One is the paraxial ray I will take, another is the pole ray I will take, which is passing through the pole. Minimum 2 rays. Always one is paraxial, another should pass through the pole only. Then only we can understand the ray diagram properly. Then after that, where I will get the image, nothing but I will get the image between the C and F. Very good. We will get the image between the C and F. So here. Okay. Now this is a larger object or smaller object? Larger object. This one is smaller image. So whenever the object is beyond C, at that time where you will get the image? Image in between C and F. And also it is real or virtual? Real image. Erected or inverted? Inverted image. And then enlarged or diminished? Diminished image. Clear? This is about the beyond C. Next, third case is the object is placed on C. Object on C. Now my object is there like this. I need minimum 2 rays in this way. Where the image will be formed? Where the image will be formed? On C only again. Same size or different size? Same size. So I will get my reflected rays in this way. Ayyo. Puchuk. ಹೌದು ನೀವು ಇದ್ರವಲ್ಲ ಅದಕ್ಕರೆ you know right, you only draw. Okay, little bit okay, manageable. Yes, same size hai na? Let us consider this is the same size only. So now I can get my image in the same size. Where we will get the image? On the center only. Whenever we have taken the object on the center means image also on the center only. And also the image is which type of image? Real or virtual? Real. Erected or inverted? Inverted. And then enlarged or diminished? Same size. Very good. Wow. Highly focused students. Paramanande Shishar ellaru. Waiting for the snacks. Correct? Yes sir. ನೋಡ್ರಿ ನಾಚಿಕೆ ಇಲ್ಲ ಏನಿಲ್ಲ. ಡೋಂಟ್ ಮಿಸ್ ಏನೇ ಓಡಿ ಇಷ್ಟು ಸೀರಿಯಸ್ ತಗೊಂತ ಇದ್ದಾರೆ ನನಗೆ ಅನ್ಕೊಂಡಿಲ್ಲ ನಾನು. Yeah, now this one you have to concentrate, mainly focus. Now the object is in between the C and F. Where you will get? Beyond C. Exactly opposite to this one. Okay, same as this one. Now we will get the image here, that is enlarged image you will get. So this is enlarged image. Real image or virtual? Real image. Erected or inverted? Inverted. And then enlarged or diminished? Enlarged. Then fifth case. See that how I teach in the crash course. Ba. ನೀವು ಬಂದೇ ಇಲ್ಲ ಕ್ಲಾಸ್ಗೆ, ನಾನು ಮಾಡಿದ್ದೀನಿ. ಜೈ. Now ಎಲ್ಲಿ image will be at infinite. So infinite image will be at infinite. Now which type of image this is? Real image it will be, and then enlarged will be there, and also inverted. And also because it is formed at the infinity, we don't have any clarity about the nature, just we are assuming like that, but the nature cannot be defined whenever the image is formed at the infinity. Why? Because it might be erected or it might be inverted. We cannot say the answer for that. So next one is, next case. Now you have to mainly remember in this is, just whenever we place at the focus, object is placed at the focus, at that time my image is formed at the infinity. Then next case is last one, that is the object is there in between the focus and then pole. At that time what happens? The image will be formed behind the mirror. It is forming behind the mirror means which type of image that is? Virtual. Very good. And also that will be enlarged. I will draw the diagram, you can understand that properly. Now I have just drawn a straight paraxial ray, and then another ray is passing through the pole. Then this paraxial ray obviously reflect back through the focus, and the next one obviously the angle of incidence is equals to angle of reflection, like this it will be there. Those are not parallel, by the way, the angle will be completely different angle, like this. Now whenever I extend them in the opposite direction, I can form an image known as which type of image? That is virtual image. We are just extending nothing but that is a virtual image, and then that is enlarged image. Why? Because my object size is very smaller and then image we got larger, so that enlarged. And after that we can say it is erected or inverted? Erected. Clear? Why? Because in the same orientation. Clear all the diagrams? First one is whenever the paraxial rays are coming, where the image will be formed? Focus. That is real or virtual? Real. Erected or inverted? Inverted. For the point size we cannot say that, but the enlarged size it will be inverted only. And also enlarged, otherwise diminished. Highly diminished. Whenever the object is placed beyond C, at that time where the image will be formed? Between C and F, and also the image is smaller, nothing but diminished, and also real image and inverted image. Then next one is whenever the object is exactly placed on the center, then what happens? Image will be also on the center only, same size and inverted and real. Okay. Then next one is whenever the object is placed between C and F, image will be formed beyond C, and that will be enlarged, inverted and real. The next case is whenever the object is placed on the focus, at that time the image will be formed at infinity, and generally whenever we compare all the cases it will be highly enlarged, and I can say it might be inverted or it might be erected. Okay, we cannot say the nature properly. Then after that next one is whenever the object is placed between the focus and pole, at that time where the image will be formed? Behind the mirror. It is forming at the behind nothing but that is virtual image, and also that is enlarged image. Clear? And erected, by the way. So last one is completely different, that is erected, and then everything will be inverted only. And also here one shortcut I will tell you that whenever the object is there at the larger distance, then image will be the smaller. So only I said that object is there at infinity, nothing but I said highly diminished. Object is there beyond C, nothing but my image also diminished here. Clear? Whenever the object is coming near to the pole, at that time I can form the enlarged images. So only whenever it is at infinity, we are getting highly diminished. We are getting beyond C, nothing but just diminished. On the C means same size, and then between C and F, nothing but we got the enlarged image. So only as the object is coming near to the pole, my image size will get increases. Clear? Whenever the object is away from the pole, nothing but beyond the C, at that time my image size will be very smaller, that is diminished. Clear? Even here also you can observe that the object is still coming near to the pole. At that time the image size will be enlarged here. Clear? Write the nature in each and every case. For the extended object at the infinity, where the image will be? For the extended object at the infinity, where the image will be? Focal plane. Focal plane. Okay, na? Write the nature in each and every case. This one you draw little bit bigger, enlarged. Last one is completely different. దీనికి ఆఫ్ చేయమా